Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to finish up our discussion of systems of equations by looking at some word problems regarding systems of equations. So nothing really new here today. We've already learned how to build equations from reading word problems, and we've already learned how to solve systems of equations. So we're just going to be putting those two concepts together. So let's dive right in with this first problem. First problem says Mr. Fawcett spends 3 minutes grading each entry ticket and 10 minutes grading each exam. Over a random weekend, he had a total of 97 assignments to grade and spent 746 minutes grading. So we're going to let X represent the amount of entry tickets Mr. Fawcett had to grade, and let Y represent the amount of exams Mr. Fawcett had to grade. Okay. This first problem, I walk you through it, right? I say, write an equation that incorporates the total amount of time Mr. Fawcett spent grading. So think about what our variables are. Think about what the problem said about the total time spent grading, and see if you could come up with an equation that represents total time spent grading. Okay, so the total time spent grading, right? Well, that's split between the entry tickets and the exams. So we would have time for entry tickets, or ET, plus time for exams. That should equal the total, right? Okay, so the time for the entry tickets, well, it takes 3 minutes for each entry ticket, and I had X entry tickets. So 3 times X. For the exams, I had 10 minutes for each exam and Y exams. I don't know how many, we're just letting Y equal. So 3X plus 10Y. And it said my total time was 746 minutes. So that should all equal 746. So there's my first equation. 3x plus 10y equals 746. Now I need to come up with an equation that represents the number of assignments Mr. Fawcett had. So think about what the problem says about the number of assignments. Think about how do I use my x and y and try to build that equation. Well, let's get rid of some of this. I know that let's write this out in words first. All right, so number of entry tickets plus number of exams. Right, that should equal the total. Well, the total amount of entry tickets I had, that's just X. I've already underlined that right here. Total number of exams is Y. And we know that the total number of assignments is 97. So we have X plus Y is equal to 97. So I have two equations, and part C says solve the system using either substitution or elimination. So your choice, feel free to use whatever one you think is easiest. Pause the video, attempt that way, and then see if you can come up with the solution. Okay, let me give us some more space here. We had 3x plus 10y equals 746. And then we had x plus y is equal to 97. I'm just going to use elimination here. I'm going to multiply my second equation by 3. And I'm going to get rid of the x's, or I'm going to eliminate the x's. So I have my first equation, 3x plus 10y is equal to 746. My second equation becomes 3x plus 3y is equal to 291. So I'm multiplying everything by 3. Now I don't want to add these equations together because that's not going to eliminate the x's. I want to subtract. And remember, I have to subtract every single term. So you can either think about it as subtracting everything that's purple, or you can think about changing all of the signs first. I'll just talk about it as subtraction. So if I do 3x, oops, I don't know why this keeps disappearing. 3x minus 3x, it gives me 0 x's, so those are just eliminated. 10y minus 3y gives me 7y. And 746 minus 291, let's make sure I get this correct, that's going to give us 455. Well, last thing to do would be to divide both sides by 7, and that's going to give me y. Whoops. That's going to give me y is equal to 65. Last thing to do, well, for just solving, is substitute that y back into one of the equations. It's actually going to be much easier to do it in the second one. So x plus y equals 97. Instead of y, I get 65, so I get x plus 65 is equal to 97. Subtract 65 from both sides. And we're going to get x is equal to 32. Because this is a word problem, we need to have a conclusion, right? What does x and y mean? We need to write that out. So, Mr. Fawcett had 32 entry tickets, because that's what X stands for. Oops. And 65 exams to grade. Remember, it's always good when you have a word problem, write a little conclusion so the reader knows that you understand what those variables represent. All right, let's do 2 more. Let's jump down to number 3. It says Microsoft is running a cost analysis to see if it will be profitable to build a new gaming system. It would cost them $20,000 to build a small factory, and then it would cost them $20 to build each console. They would plan on selling each console for $250. So the first thing we need to do is write a cost equation that represents the total cost, which will be in dollars, for Microsoft if they build a certain amount of Xboxes N. So let's write this equation out in words first. We need to think about what are the things that go into the cost for building the Xboxes. Well, there's the factory cost, right? Then we have the cost per console to build. And that should be equal to the total cost. Well, the cost for the factory, $20,000. Whoops. The cost per console is going to be $20, but we don't know how many consoles they're building. So it's going to be 20 times the number of consoles, or times the number of Xboxes, which is N. So 20N. And our total cost, we don't know what the total cost is, but they tell us that we're going to use C for the total cost. So 20,000 plus 20N equals C. Part B says write a revenue equation that determines the amount M that Microsoft makes from selling a certain amount of Xboxes. So we have to think, okay, how much money do they make from selling? Well, there's only one thing that they make money from. There's only one thing that they make money from when they sell, and that's money from each console, or from each Xbox. That's not how you spell console. That's better. And that is equal to the revenue. Different color. Revenue. So the money from each console, or the money from each Xbox, is 250 times N, because that's the number that they'll sell. And it tells us that our revenue is going to be equal to M. That's what's going to represent our revenue. So there's our second equation. So we have two equations, one for the cost, one for the revenue. And part C says, if Microsoft sells 230 Xboxes, will they have made a profit? Show work that leads to your answer. Well, profit is when revenue is greater than your cost. So if the revenue they make, if the amount they make from selling the Xboxes is greater than the amount it takes them to produce the Xboxes, which is their cost, then they will have made a profit. So let's see. We'll put our cost over here. So 20,000 plus 20 times 230, right? Because they're telling us that they are going to produce 230 of these Xboxes. Well, if I simplify the left-hand side of this equation, I get 24,600. So that is the cost of producing 230 Xboxes. Now let's look at the revenue, rather. So the revenue is 250 times 230. So 250 times 230, that gives us 57,500. So we can say yes. Yes, they will make a profit. Because revenue for 230 Xboxes is greater than the cost. And that's what businesses are looking for, right? They want the amount that they sell to be greater than the amount that it costs them to make those items. Otherwise, they're going to go out of business, right? Because they're never going to make any money. Okay, there is one more part to this. There is a part D down below. And part D says, find the number of Xboxes that Microsoft will need to sell such that their revenue is equal to their cost. Well, remember, we have revenue, M equals 250 times N. And we have the cost equation, right? That's, whoops. I'll write it like this. C is equal to 20,000 plus 20N. So we're trying to figure out the amount of Xboxes, or the N value, such that their revenue is equal to their cost. Well, if revenue equals cost, then I need to have 250N being equal to 20,000 plus 20N, right? I'm setting the revenue equation equal to the cost. There's actually one more. You could actually put one more line in here if you wanted to, just to show the relationship, right? Revenue is M, cost is C. So M is equal to 250N. C is equal to 20,000 plus 20N. And this is a very easy equation to solve, because it's already one variable. So I'm going to get 230N is equal to 20,000. And I'm going to divide both sides by 230. And you actually don't get a whole number here. You get N, whoops. you get n is approximately equal to 86.96. So there's not a single number actually where they'll have their cost exactly equal to their revenue, right? If they sold 86 Xboxes, then their cost would be slightly more than their revenue. And if they sold 87 Xboxes, then their revenue would be slightly more than their cost. So it's between the 86th and 87th Xbox where their revenue is going to pass their cost. So once they get to 87 Xboxes, they will be in profit. Their revenue will be greater than their cost. And if there was a question on the exam, it would probably be, one where this value comes out to be a whole number. But, in real life, not always will things come out nicely. So we have to think about, okay, if we get a fraction here, what does that mean, right? Well, it means if we sell less than 86.96, so 86 or fewer Xboxes, our cost is more than our revenue. And if we sell more than 86.96, so if we sell 87 or more, then our revenue is going to be greater than our cost. Okay, let's look at one more before we are done for this lesson. We're going to look at number 4. So it says, Mitch gets paid at home for doing extra chores. Last week, he did 4 loads of laundry and 8 loads of dishes, and his parents paid him $32. The week before, he finished 2 loads of laundry and 8 loads of dishes, earning a total of $24. So part A says, write an equation to represent the week where Mitch made $32. X is going to represent the amount of money he gets for doing laundry, and Y will represent the amount of money he gets for doing dishes. Part B says, write an equation to represent the week where Mitch made $24. And our variables, of course, are going to be the same. So I'd encourage you to pause the video, see if you can come up with both of those equations. Both equations will have an X and a Y. So see if you can come up with both of those, and then we'll think about how to solve that system. Okay, so for both weeks, our setup is going to be very similar. It's going to be money from laundry plus money from dishes equals the total. So money from laundry. Well, he makes X money for each load of laundry, right? So we don't know the amount of money for each load, but we do know the amount of loads for this week, where he makes $32. That is the week he did 4 loads of laundry and 8 loads of dishes. So 4 loads of laundry, and he gets paid X amount of dollars for those. So it would be 4 times X. For dishes, he did 8 loads of dishes, and he gets paid Y dollars for doing dishes. So 8 times Y. We do know the total. The total is $32. So this is our first equation. 4x plus 8y equals 32. For the second week, again, similar setup. So the money from laundry, well, he did 2 loads of laundry, so 2x. He did 8 loads of dishes still, so 8y. The total this week was only 24. So 2x plus 8y equals 24. Go ahead, your choice. Figure out how to solve that, whether it be substitution or elimination, and see if you can come up with the x and y value. I'm just going to give us some more space. All right, so we have 4x plus 8y is equal to 32. And we have 2x plus 8y is equal to 24. And again, I think elimination is probably the easiest here, right? There's no variable that's already by itself, so we would have to go through the process of getting y or x by itself and then substituting. probably easier to just use elimination here. And it's actually really nice, right? Because we already have two coefficients that are the same, the y's. So we can go ahead and subtract these equations and immediately eliminate the y values. So let's go ahead and do that. 4x minus 2x gives us 2x. 8y minus 8y is 0y. And 32 minus 24 is 8. So we've easily eliminated the y's. Divide by 2 to solve for x, and x is equal to 4. Let's go ahead, substitute that into the first equation. 4x plus 8y is equal to 32. We know that x is equal to 4. So we're going to get 16, not equals 8y, plus 8y. All right, let's just make that a bit more neat. There we go. 4 times 4 is 16, plus 8y is equal to 32. Subtract 16 from both sides. And we get 8y is equal to 16. Divide both sides by 8. And we get y is equal to 2. So again, let's think about what does this mean? What do the variables x and y mean? Well, x represented the amount of money he got for doing laundry. Y represented the amount of money he got for doing the dishes. So we can write a little conclusion and say Mitch makes $4 for each load of laundry and $2 for each load of dishes. Dishes. And we are done. That would be a complete and acceptable answer. Okay, a couple problems we didn't do, so you can work through those on your own, the process of setting up the equations, and then choosing whether substitution or elimination is the most efficient. But I am going to leave you there. Enjoy the rest of your day, and we will see you for our next lesson.